It started with a whisper, a distant rumble beneath the earth, too soft for anyone to notice. Then boom, in less than a heartbeat, the ground split open. Buildings swayed like trees in a storm. Car alarms screamed, and in that moment, everything changed. Across history, earthquakes have reshaped civilizations in the blink of an eye. From the towering ruins of ancient Pompeii to the modern high-rises of Tokyo, the power of the Earth's shifting plates has humbled even the greatest megastructures. Deep beneath the surface, massive tectonic plates are locked in an invisible battle. For decades, they press against each other, building pressure, until, suddenly, they slip. This violent release sends shockwaves racing across the land, shaking everything in their path. In Myanmar, the recent 7.7 magnitude quake was a brutal reminder of this force. The once stable streets of Mandalay cracked like glass. Towers crumbled, and an entire nation was left reeling. But why does this happen? And more importantly, can we build to survive it? From the towering skyscrapers of New York to the ancient temples of Bagan, every structure faces the same test. When the ground moves, will they stand or will they fall? Today, we dive into the science, the destruction, and the future of earthquake-proof megastructures. It came without warning, a sudden jolt beneath the feet of millions. In the heart of Myanmar, the earth groaned, then roared. And in just 45 seconds, centuries of history, homes, and hope crumbled to the ground. On the morning of March 28, 2025, Myanmar was shaken by one of the most powerful earthquakes in its history, a 7.7 magnitude monster that struck near the city of Myanmar. The epicenter? Deep beneath the soldering fault, a geological fracture running like a scar through the nation. This fault, one of Southeast Asia's most dangerous, had been silent for decades. Until now, in the capital Naypyidaw, the air traffic control tower collapsed mid-transmission. In Mandalay, entire neighborhoods were flattened, and historic temples, some standing for over 1,000 years, suffered devastating cracks. More than 1,600 lives were lost, thousands injured, and many still missing. The impact wasn't just local. The tremors rippled beyond Myanmar's borders, shaking cities in Thailand, India, and even Bangladesh. In Bangkok, a high-rise swayed violently before crashing into the streets below. This was more than a disaster. It was a wake-up call. Can Myanmar rebuild? And more importantly, can it prepare for the next one? They were built to last a century, but in less than a minute, they were left in ruins. Glass shattered, steel bent like paper, and as the ground shook, these megastructures, once symbols of human ingenuity, became monuments of destruction. Earthquakes don't discriminate. They strike the tallest towers, the longest bridges, and the busiest airports, turning modern marvels into deadly traps. When Myanmar's 7.7 magnitude earthquake hit, its megastructures faced their toughest test. In Naypyidaw, the airport's control tower collapsed, cutting off vital communication. In Mandalay, a newly built high-rise swayed violently before tumbling into the streets. And across the Irrawaddy River, a major bridge cracked, its foundation sinking into unstable soil. The problem? Many of these structures weren't designed to handle this level of seismic force. While countries like Japan and the US engineer skyscrapers with flexible foundations and shock absorbers, Myanmar's aging infrastructure lacked these defenses. Across the world, over 150 megacities sit on major fault lines. Tokyo, Los Angeles, Jakarta all face the same risk. The question is, are we building to survive or simply hoping for the best? Because the next quake isn't a question of if, but when. It stood as a beacon of control, guiding planes through the sky. But in just seconds, the Naypyidaw Airport Control Tower became nothing more than dust and debris. The question is, why? On March 28, 2025, Myanmar's 7.7 magnitude earthquake didn't just shake the ground, it shattered the very foundation of the nation's infrastructure. Among the casualties was Naypyidaw International Airport's control tower, a structure critical for communication and air safety. As the quake's seismic waves rippled through the capital, the tower buckled under intense lateral forces. Engineers now believe its rigid, outdated design played a key role in its failure. Unlike modern earthquake-resistant towers built with shock-absorbing bases and reinforced flexibility, Naypyidaw's tower relied on traditional vertical supports, unable to withstand the violent shaking. When the first tremor hit, cracks spread through the concrete like veins of destruction. Moments later, the structure collapsed in on itself, silencing air traffic control at Myanmar's busiest airport. This wasn't just a disaster, it was a lesson. Across the world, control towers, skyscrapers, and megastructures stand at risk. The question remains, will we reinforce them before the next earthquake strikes? Or will history repeat itself? The earth shakes, the ground splits open, but the buildings? They don't fall. What makes some structures collapse while others stand tall? For centuries, earthquakes have flattened cities, leaving destruction in their wake. But today, engineers are fighting back with science, innovation, and design. At the heart of earthquake-resistant buildings lies a simple idea: flexibility. Unlike traditional rigid structures, modern skyscrapers are designed to move with the quake, not against it. Take base isolators, for example. Massive rubber and steel bearings that sit beneath buildings, absorbing seismic shocks before they can reach the structure. Or tuned mass dampers, giant counterweights hidden inside towers that sway in the opposite direction of an earthquake, reducing vibrations. In Japan, entire buildings are equipped with seismic shock absorbers, allowing them to ride out quakes like ships on rough seas. In California, steel-reinforced cores and cross-bracing create flexible but unbreakable skeletons for skyscrapers. The technology exists. The solutions are clear. The only question is, will we build smarter before the next big quake hits? Or will we wait until it's too late? Two earthquakes, same magnitude. One city stands, the other crumbles. What makes the difference? The answer isn't luck, it's engineering. In Japan, where earthquakes are a part of life, cities are built to bend but not break. Skyscrapers sit on base isolators, absorbing shock before it reaches the building. Underground, massive counterweights shift, keeping towers upright. Entire neighborhoods are designed with flexible steel frames and reinforced concrete, ensuring safety even during the most violent quakes. In California, engineers use deep foundation systems that anchor buildings into bedrock. Bridges are reinforced with seismic expansion joints, allowing them to flex without collapsing. The famous Transamerica Pyramid in San Francisco can sway more than a meter in any direction without toppling. But in Myanmar, the recent 7.7 magnitude quake exposed dangerous weaknesses. Many buildings relied on brittle, outdated materials, lacking modern reinforcement. Bridges collapsed, homes crumbled, and lives were lost. The lesson is clear: seismic safety is a choice. Countries like Japan and the US invest in life-saving engineering, while others are left vulnerable. The question is, will Myanmar learn before the next disaster strikes? After the devastation, there's a choice: rebuild what was lost, or rebuild stronger than ever before. Myanmar stands at the crossroads. What will it choose? The earthquake that rattled Myanmar was a wake-up call, not just for the people, but for the country's future. With a growing population and increasing urbanization, Myanmar must future-proof its infrastructure to withstand the inevitable next quake. Rebuilding efforts are underway, but this time, the goal isn't just to rebuild, it's to transform. Modern engineers are already advocating for seismic-resistant designs in the city's next wave of construction. Buildings will be built with flexible steel frames, shock-absorbing foundations, and tuned mass dampers, technologies that have already saved lives in other earthquake-prone regions. Cities like Tokyo and San Francisco have shown the way. Use innovative materials and smart engineering to create buildings that bend without breaking. Bridges will be reinforced with seismic isolation systems, able to absorb the shock of a quake without cracking under pressure. But rebuilding is not just about technology, it's also about education. Engineers, architects, and government officials must work together to embrace seismic safety, learning from countries that have faced the same challenges. Myanmar's path forward isn't just about recovery, it's about resilience. And it begins with choosing strength over fragility. The earthquake shook Myanmar to its core, but also sparked something even more powerful, the chance to rise again, to rebuild with purpose and to protect the future. Will we seize this moment? The events of March 28, 2025 were a stark reminder of the power and destruction earthquakes can bring. In the wake of the devastation, one thing has become clear. We must rethink how we build. The world has seen the toll earthquakes take, and it's time to ensure that no city is left vulnerable to their destructive forces. Countries like Japan, the US, and Chile have long been at the forefront of earthquake-resistant design, implementing flexible foundations, shock-absorbing systems, and reinforced steel frames. These methods save lives. They protect economies. They ensure that the cities of tomorrow will stand strong against nature's fury. Myanmar is no different. The question is, will it choose to build a safer, more resilient future? From the rubble of this tragedy, there's an opportunity to create something greater, an infrastructure that embraces innovation, strength, and foresight. It's not just about rebuilding, it's about future-proofing. Every city, every megastructure, every bridge built must be designed to bend, but never break, to absorb the shock and stand tall no matter what comes next. The time for action is now. Let's build better, build safer, and build for the future.